Students, today I will discuss complex analysis. What is complex analysis? Complex analysis is the branch of mathematics that deals with the function of complex variable and it extends concept of calculus. Complex analysis plays a fundamental role in the area of mathematics. So now we start complex analysis. Complex number. First we will discuss complex number. Complex number. What is complex number? Z equals to x plus iy, where z equals to x plus iy, x is the real part and iy is the imaginary part. Imaginary part, and I is the imaginary unit. I equals to imaginary unit, which I square equals to -1 and I equals to -1 la root over of -1. That is called complex number. And what is complex function? ये है complex number. What is complex function? Complex function. What is complex function? Complex function that maps complex number to complex number. Suppose f is a function f of z is a function which maps complex number to complex number. That is complex function. And I will discuss analytic function. Analytic function, which is the keywords of complex analysis. What is analytic function? A function is called analytic if it is differentiable at every point in its domain. A function is analytic if it is differentiable at any point in its domain. At any points in its domain. And singularity. What is singularity? Points where a function, singularity points where a function cases to be analytic. And in complex analysis, an analytic function is a complex function that is differentiable every point in its domain. For a function to be analytic, it must satisfy the Cauchy-Riemann equation. So now let's discuss Cauchy-Riemann equation and see some example. Let's start. Equation or Cauchy-Riemann equation. Let f of z equals to ux, y plus iv x, y, which z equals to x plus iy. X plus iy is a complex number. Ux and y. Uxy is the real part of this equation, and vx, y is the imaginary part. X and y is the real variable. X and y real variable. And Cauchy-Riemann equation says del u by del x equals to del v by del y, and del u by del y equals to minus del v by del x. These two equations are the partial differential equation that relate the real and imaginary part of f of z. Analytic function. For a function to be analytic at a point of z0, the partial derivative of del u by del x, del u by del y, and del v by del x, del v by del y must exist and to be continuous. The CR equation must be satisfied z0. So let's see an example. Consider the function f of z equals to z square equals to x plus iy whole square, which is x square minus y square plus 2ixy. Solution. Let's check the CR equation first. Consider the function f of z equals to x plus iy whole square. So ux comma y, this is u part and this is v part, x square minus y square, and vx comma y 2xy. Let's check if CR equation are satisfied or not. Del u by del x equals to 2x and del v by del y equals to 2x. Del u by del y equals to del u by del y minus 2y and del v by del x equals to 2y. So our CR equation, del u by del x equals to del v by del y, or del u by del y equals to minus del v by del x. So this del u by del x equals to del v by del y and del u by del y minus del v by del x. So the equation satisfied. So this equation is analytic. Now let's see another example. Which of the following is satisfied the CR equation? Option A, f of z equals to z bar equals to x minus iy. Which is violated? The CR equation are violated. हमारा था z equals to x plus iy, but यहाँ x minus iy which is equals to z bar. The CR equation are violated. And the option B, f of z equals to z square which is equals to x plus iy whole square. X plus iy whole square which is equals to x square minus y square plus 2xyi. This is the real part and this is the imaginary part, and it is satisfied the CR equation. So option B is correct. And C, e of x f of z equals to e of x into xy plus I sin y, which is equals to ex cos y plus e of x I sin y. This is real part and this is imaginary part. So this equation also satisfied the CR equation, u plus iv. So this option is also correct. And D, f of z equals to z plus z bar equals to 2x. So it's purely real function and does not satisfy the real CR equation. So option B and C are correct.